radius. Granger, you're going to have to use just string maybe to do this. And while they're doing the next part, I'll explain what we did on the first part since I forgot to cut that recorder on. All right, so most everybody in the class is seeing that we've got 6 plus a little extra, right? So we went around 6 times, and then we had a little bit extra, but we got a few that have exactly 6 for that. So what you're going to do next, well, let's just go ahead and tell Granger what we did right here since I forgot to record. So Granger, we took our piece of string, and we measured out the length of the radius, and then we put that piece of string right here at point M, and then we went around the edge like so. We labeled, well, it's not lined up very good. We labeled that point at the end of the string A. And then we took another piece of string that was that same length as the radius, and we went over here and did B. And C, and so on. They went all the way around. I quit early. All right, so the next thing that we are going to do is we are going to take a straight edge. You can just use the edge of your protractor, and you want to draw a straight line between the vertex, or the center of the circle, and these points on the edge. So you'll have like this point, and then, oh gosh, there we go, this point, this point. You guys are going to go all the way around. I really need to do the next one so you guys can see what happens there. All right, and you have gone all the way around. I'm stopping here just because. Okay. And so you'll have, some of you will have exactly 6 slices of the pie. Some of you will have 6 plus a little bit extra slices of pie, a little tiny sliver of pie. So, 5 just gives you the directions here. Draw the line, draw a line to each point. That's what we're doing. And then we're going to measure and label each angle that is formed by the radius shown and those lines. So that's going to be, for example, MJA is this angle right here. MJA, we would be measuring this angle here. Then we'll measure MJB and MJC and MJD and so on around. I made that table go out probably a little further than you're going to need it to. You'll have a couple you'll just leave blank because we don't have those points. I did that so as to not give away what was happening. So, so some of you may not have used a protractor before, or if so, it's been a long time. So to use a protractor, you are going to, you can flip it around either way that you want, but the point right here, like the vertex right there, needs to be at the point where your vertical and horizontal lines are crossing right there. And so you want to line up this line right here with the, you want to line up that line with the radius that is drawn, not with the other lines. You want to line this line right here up with the radius that is drawn. Now, be careful with this because you got to choose what set of numbers to look at. Some of the numbers start at 0 over here, and go around this way, and then you got these little numbers where it's 0 and around. Our first vertex, or our first ray of our angle right here is going to start right here. That's where our 0 is at. So we want to use the way I have mine turned. I need to use my inside lines. You may need to use your outside lines depending on which way you've got your protractor turned. So I'm going to follow this line on out to the edge. Again, I'm looking at those little lines, little numbers on the inside. You might have to sort of extend that out, use like the edge of your scissors or something to make it longer. I think I can probably tell. It looks like mine is about 58 right there, because this would be 60, that would be 65, so I think I'm about 58. So this angle, there goes my string. This angle right here would be 58 degrees. Now, yours may be different, so measure yours. Don't just use the same number as me to get it the same as me. Yours might be different. Now, the next angle that I'm wanting is not just this slice of the pie. It is all the way from the radius all the way around. So when you measure that angle, you're still lined up here. This angle should be bigger. It should be like 115, 120, something like that. It should not be just 60 or 58 again. What are we going to do when I got to measure something like D? Because I need to be measuring, like my angle should continue to increase, right? So I'm wanting all of them in the same direction. Add what? 180. So like, it depends on how you do it. Like if I flip this over, you're still lining it up on that axis right there. Kind of sticks to your, so, that's a little off. I'm lining it up right there with the radius, and I'm following this out. 0 this time is right here for me, and so this is between 50 and 60. I've got it like upside down for some reason, but we're between 50 and 60. And I'm right here, and I'm measuring this angle right here, and I'm getting like 53, I think, 53. But this far around was 180, so I do 53 plus 180 for that. So whenever I do that, I get, what, 53 plus 180. Like all the way around here, that would be like 233 degrees, right? That's the angle all the way around to D on that. Now you want to do every single angle. I was just skipping ahead to show you what you do whenever you get to that bottom part. And then you want to record these numbers in this table, so you're going to have like, I've got 58 right here, all the way to D, that was 238. You're going to have values in between on yours. So take a little time and find all of those angles for me. I've already seen that, like, it looks like most of us are getting 6 lengths of chain, of string. For this first angle, I got 58. Did anybody have anything less than 58? 56? I think you did not measure something right. I think you may have. Yeah, check that one again. Let's go 56 is our lower. If you have a little lower, it's fine. What about highest? Higher than 58? What'd you get? 59. 61. So 56 to 61-ish. We're in that range. Most of you falling somewhere in between there. All right. For the second one, what did you guys get? Probably like 120. All right. What lower than 120? What did you guys get? 118. What? 113. Did anybody get higher than 120? What'd you get, Holly-Ann? 123. A little bit bigger range. All right, for the next one, some of us are like a little less than 180. Some are a little above 180. Somebody got less than 180. Did anybody get 175? 175, 169. It's probably going to be one of our lower ones. Did anybody have above 180 on that? What'd you get? 190. Okay. Our ranges are increasing a little bit here. But they kind of should do that, right? Because if we were apart a little bit, we might be further apart as we go on. All right, what about for 4? For the fourth one here? 232. That sounds like a pretty good lower one. All right, probably some of you got 240. Did you get, anybody get higher? I think you measured that wrong. Okay, you got 290 on the next one. What? 244? 253? Okay, so we can see it getting a little more. Well, actually, we're about the same spread as we were on the last one, right? All right. Notice also, like, the same people that are telling me the lowest numbers are telling me the lowest numbers several times in a row, and Benjamin has the highest numbers every time, more or less, so that is significant to think about. All right, so 5, what have we got for it? 290. 307. What'd you get? 316. 288 is a little bit lower. Let's use that. Okay. All right. So we're in the ballpark. What about number 6? 357. I bet we had one lower. 351. 350. And then, Benjamin, you went past 360, right? 372. You went past 360. And I had a couple of you look like you went past 360.
Wow.
So, now, notice, Benjamin's numbers were the highest numbers every time, right? And Lucas and Webb and a couple others, you guys were consistently on the lower end, more or less, right? So, something to notice here. Here's my question. Which one is best? Which one's right? Should it have been a little over? Should it have, we're feeling Benjamin.
You know, I'm thinking it's one of the little tricks where none of it's right.
No, there is this is math class. There's a right answer, Joshua. So there's actually a very precise right answer to this, where if you had done this perfectly, there is exactly a number that you would get. So, it has something to do with pi. So, what's your string showing on that circle? Circumference. It is also the radius. Each little piece of string is the radius, right? And and all of the pieces of string together is giving us the circumference, right? What is our formula for circumference? Circumference equals 2 pi times the radius. Okay? So, what, again, were each one of your little pieces of string? The radius. How many pieces of little string should you have going around the edge? 6.28. If we really want to be precise, 2 pi, right? Exactly 2 pi, which is 6.28. So if you had done it perfectly, then you would have exactly 2 pi pieces of string around the edge. Did it matter what size your circle was? It did not. Now, I will say, I've noticed in second period and in this class, the people that had the small circles, in Benjamin's defense, the people that had the small circles were more likely to have it like go all the way around. I think just because it's a little harder to be as precise on those small circles. And you were very close to it overlapping as well. So I think that the small circles were more difficult to do correctly, whereas the big circles were a little bit easier to deal with. But you should have 2 pi. So when you see radians, because I honestly, for many years, I knew how to use radians. I understood radian measure, but I didn't really know what a radian was until I went to a workshop and we did a activity similar to this, and they explained that the radius, 1 radian is the angle that goes with 1 radius length of the arc on the circle, right? And so you guys may have already known that, but I definitely didn't before I went through something like this. So a radian can be used. It is actually the arc length of the circle. It's how many radii around the circle you are going, but that will always correspond to the same angle. Because if we had done this perfectly, we would have all gotten exactly 6.28 blah 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 pieces of string, right? And all of those angles would have fell exactly at the same spot, right? We would have had everybody's angle, if we had done it perfectly, would have been the same. Now we noticed we had similar angles, right? As we went around. Everybody's first angle was should have been a little less than 60 degrees. Some of us were a little over, but we were seeing trends. Like if we were over the whole time, right? The thing that you should notice about those angle measures there is that they are all very similar. Let's skip on down here. Using the pattern that you see, how many lengths of string would it take to get to 180 degrees? Okay, and even more precisely? Yeah. Yeah. So pi, or about 3.14 pieces of string it would take there. So this should teach us, well, first of all, each length of string as we go around is called a radian. And it goes with an angle that has a measure of a radian. So I'm going to actually put 2 things right here. A full circle, right, 360 degrees is 2 pi radians. And the one we actually use a little more often, 180 degrees, is going to equal pi radians. There. Yeah, whenever I saw this at that workshop, I was like, why have I not known this before? But it's possible to use this for measuring angles. Now, in AP Pre-Calculus, everything on your AP exam is going to be in radians. There will be no degrees on the test. So it does mean your calculators need to be in radian mode, and always in radian mode. Like the day before, we're going to all put them in radian mode, and you're not going to touch them until we take the test. Because if you reset your calculator, second plus sign 712, it's going to go back to degrees. No, wait, maybe it's radians is default. Actually, radians I think is the default on those. So you might be okay, actually. But we are only in radians. I want us to learn just a little bit about degrees, because in like physics, sometimes if you take physics, they'll use degrees instead of radians. And we're more familiar with degrees. If I'm asking you to estimate what the angle is, you would probably tell it to me in degrees. You're not as familiar with radians yet. So I do want us to do that some for this. So tonight you are going to have an assignment. And if you want to pull up your computer, you can go ahead. We got about 15 minutes. You might get a few of these done. And it's going to be on Delta Math. So if you'll go to Delta Math. So today, after hopefully understanding a little more about what a radian is, we're also going to convert from radians to degrees. Now, this is not something you are going to be asked to do on your exam because everything's going to be in radian measure. But I think it's a little helpful to do some converting from radians to degrees and degrees to radians so that we can estimate what is equivalent there. So let me pull up the sample student page here. Have all of you had chemistry? A couple of you you're taking it right now. Are you in chemistry? Okay. Have you guys gotten to the part where you're like converting units? So you have like miles per hour and you're converting it to feet per minute or feet per second. You probably don't, yeah. Have you gone from like kilometers per hour to meters per second sort of thing? Okay, so. I've not done it. Okay. You do. I'm not exactly sure how she does it, but it's in there. Yeah. But I'm going to use a similar method to that. So if you, I'm going to teach you how to do it, but just to relate. So, so if we, oh wait, wrong thing. Let me get my pen. All right, so this first one says convert the angle 5 radians to degrees. Now you can look at your paper and get an idea of what 5 radians is, right? Look at your paper, look at 5 string lengths around. What was yours about? 300 about 300, somewhere around 300. So that's like an estimate. So that, to me, this really helps me to picture what 5 radians looks like and to think about what it would be in degrees for that. So, but we want to know exactly what it is, rounded to the, well, actually, rounded to the nearest tenth. So we are going to use the calculator on this. So I right now have 5 radians. And I want to convert radians to degrees over here. So I'm pretty sure this is what Miss Hooper does in chemistry, and I definitely did it in chemistry here. I right now have radians in the, like this is not a fraction, but it could be a fraction, and it's in the top, right? So I want to put radians on the bottom, and I want to put degrees on the top. And this has to be a congruence factor here. It has to be 2 things that are equal to each other. Because if I multiply something by a value, and I don't want it to change, it's got to equal 1, right? And for something to equal 1, the top and the bottom have to be equal to each other, right? So 180 degrees equals pi radians. So when I multiply by 180 degrees over pi radians, I'm really just multiplying by 1. Because those 2 things are the same, right? If I change pi radians to degrees, I'm multiplying by 180 degrees over 180 degrees, right? These 2 are the same, so I'm not changing the value here. I'm just changing the units. So if I do that, the reason I put radians on bottom is because now radians can cancel with the radians on the bottom, right? And so if I multiply these fractions together, 5 times 180, I think gives me 900. You can use a calculator there. And 1 times pi gives me pi. And in the top, my units are degrees, because I still have degrees. But radians canceled, so in the bottom I just get pi. All right. And depending on what Delta Math asks you for, you're going to either type it into your calculator or you're going to put it in as a fraction. This says nearest tenth, so you're going to type it into the calculator. And where'd mine go for that? I'm going to do 900 divided by pi, and I'm getting 286.4788976 rounded to the nearest tenth. That is going to be 286.5 there, and I will submit my answer to yes, and that is correct. Okay, so you were just multiplying by 180 over pi if you're trying to go from radians to degrees. Now, there is sort of another shortcut. Let's look at this next problem. Because if you look at this, I'm going to show you another shortcut. Now, I definitely could do exactly what I just did on that problem. Right? I got 17 pi divided by 12 radians. All right. But what does pi equal? Pi radians, what does it equal? 180 degrees. So if you have a problem like this, 17 pi over 12 radians, like that, and it's got the pi in the problem, what does pi equal? In degrees? 180. I can just replace pi with 180 degrees because they're equal to each other. Or you can do like we just did. You can do 17 pi over 12 times 180 over pi, like that. You can do it either way. But it's a little bit easier if you just replace your pi with 180. So if I do 17 times 180 and divide that by 12, I will get 255 degrees. Or I could do it this way. I can cancel those pi's, and I'm still doing 17 times 180 divided by 12, right? Either one of those works. So on that one, we'll get 255. Does that make sense? Okay, let's go back. I'm going to look at the ones where we're converting degrees to radians now. It's very similar logic, just upside down. All right, this time I've got degrees. I need to go to radians. So if I have 465 degrees, and I want to change it to radians over here, right now, this is not a fraction, but I could make it a fraction. Degrees are in the top. Where do degrees need to go? Over here. Bottom. And radians go on top. And I need a congruence factor here, so I need things that are equal to each other. 180 degrees equals pi. It is possible to use 2 pi and 360, but that just makes your numbers bigger and harder to deal with, so I would not do that. Use pi and 180. And so if I'm on, now this one says express your answer in simplest form. It does not want a decimal here because it didn't tell us to round. So what I'm going to do is I'm going to multiply straight across like we do for fractions, 465 pi over 180. And then I want my answer to still have pi in it because if I type pi into the calculator, it's going to give me a decimal for it. So what I'll need to do, let me pull up the calculator real quick here. Where'd that calculator go? Calculator. There you are. All right, so for that calculator, I'm going to just type in 465 divided by 180 and hit math, enter, enter, and it will change it to a fraction for me. And I'll get 31, and the pi was on the top, right? So 31 pi divided by 12 radians. And if it says simplest form, that's what it's looking for. So you'll just type that in, 31 pi divided by 12. So when we need to go from degrees to radians, we're going to multiply by pi over 180. When we need to go from radians to degrees, we multiply by 180 over pi. Sometimes I get confused on which one it needs to be, but if you think about converting where your units have to cancel, if I got degrees on top right here, degrees have to be on bottom so that they cancel. So I know 180 needs to go on the bottom there. Okay, questions there? Does that make sense? So you're just converting on this. You can do a couple of them before we go. It's got help videos if you need them. It shows you the explanation for each one. Hopefully this should be something you can do pretty quickly. once you get started on it, it shouldn't be very, very terribly difficult. As always with Delta Math, if you are getting stuck on this, do not spend more than 30 minutes on it. It'll show me how long you have spent. You can come in for help on that if you're getting stuck.